Okay, this is 1.7. This is number 1. It says a spherical weather balloon is being inflated. The radius of the balloon is increasing at a rate of 8 centimeters per second. Express your surface area of the balloon as a function of time, and you can use pi as pi. Okay, so surface area, first of all, the formula is 4 pi r squared. Now it wants us to express the radius as a function of time. So let's say the radius starts up at 0, and we're adding 8 centimeters every second. We need to multiply that by t because you need to get rid of the seconds so that the radius is in a length. So you need to multiply by t seconds so that the seconds cancel, and the radius will now be a length. So that's just 8t. You get rid of the units and get rid of the 0, it's just 8t. So I'm going to enter in 8t for r, and I get 4 pi times 8t squared. Now I'm going to use pi when I go to enter that in to the computer, but that's what they're looking for. Okay, the next problem then says a circular oil slick is expanding radius r in feet and time t in hours, given by this formula right here, from 0 to 10 hours. So we want a function, we want area to be a function in terms of time. So obviously the area of a circle is pi r squared. So there's our function, but we need to get r in terms of t, so we'll just plug this in for r. So our function in terms of t for area is pi times 18t minus 0.3 t squared. That needs to be squared. And the key thing is be sure to include units. I had a hard time with that at first. It's square feet when you're done. So use pi, and then don't forget the square feet. All right, next question. It says National Park records data recording the fox population F over the month. So here's January, February, March, April, May, and so on. Is t a function of f? Okay, now at first that threw me off because I thought it was saying is f a function of t? You know, is the y a function of t? That passes the vertical line test, right? This data, as we would graph it, passes the vertical line test. But it asks, is t a function of f? So it's kind of asking about the inverse, which the inverse is not, because there's this 1.125 has 2 different values associated with it, 2 and 10. So, you know, if you were to graph that, it'd be fine. Like here's 2, and here, let's say this is 125, and then here's 10, and here's 125. That's fine for our function if we put t here and f here. But if we switch it around, it doesn't pass the horizontal line test. Therefore, the inverse is not a function. Therefore, the way they're asking this, is t a function of f? That'd technically be no. All right. Then they just want those values at 125. That's 2 and 10. Okay, next problem, you can't get any easier than this. It gives us the width and it tells us the area, which we know is length times width, is 2,800. So what's the length of the garden? Well, plug in the width is 40. Length times 40 equals 2,800, and divide by 40. That gives me 70. Okay, the next problem is problem 5. It says after robbing a bank in Dodge City, a robber gallops off at 12 miles per hour. So let's write down the robber's information. His velocity is 12 miles per hour. His time, we'll call his time t, and his distance d. Now for the marshal, he's going to have a velocity that's a little bit faster, 16 miles per hour in my problem. His time would be t. He takes off later, so he's going to be traveling for less time. So t minus, I'm going to do 0.5 hours instead of 30 minutes because they want me to give how long in hours. So I'm going to make sure this is in hours, miles per hour. So he's going to be traveling for half an hour less than the robber. And then the distance is the same because we want them to catch each other. So let's write an equation for distance for the robber, which is distance equals velocity times time. And let's write an equation for distance for the marshal, which is distance equals velocity times time. And we can set these two equal to each other. And we can solve by distributing. So we get 12t equals 16t minus 8. Subtract 16t from both sides, and you get negative 4t equals negative 8, which is obviously t equals 2. hours. Now, that's how much time goes by for the robber, right? But here, the marshal, he doesn't leave for half an hour later, so it's 2 minus 0.5, which is 1.5. And that's what they wanted it. How long did it take the marshal? In this case, it's 1.5 hours for my problem. Okay, the next problem says, suppose you're taking a test. A course has 4 tests. 3 tests are worth 100, and the 4th test is worth 200. So 84 plus 81 plus 81 plus this 4th test, all over, that's a total of 500 points. It needs to give you an 80% in the class. So just solve for that. If you multiply both sides by 500, and then subtract these numbers over, you get x equals 154. And for some reason, that's what it wants. I thought it'd want a percent because it says, no, that makes sense. Minimum score you need. So 154 out of 200. So just put 154. Okay, next question. It says that 270 is 35% of what number? So 35% is 0.35, of is multiply, what number would be x equals 270. So pretty easy to set up that equation, and obviously really easy to solve it as well. It gives me about 771.43-ish. All right, for now I'm going to have to make this question extra credit. I can't get the right answer. I don't know what I'm doing wrong. I set up 2 equations as rates, hours per job, solved the system and got the wrong answer. Not sure how to solve it, so I guess we'll have to throw this off the homework for now. If I can't do it, we'll make it extra credit and we'll spend some more time on it later when we have more time, if we want. Okay, the next problem then says that we drove an average of 50 miles an hour from city A to city B, and stayed in city B for 25 hours, and then went 55 miles an hour back, and then returned home 49 hours after leaving. So 49 minus 25 gives us 24. So we were driving for 24 hours. That's what I want because I'm looking at rates and distances here. It asks for how many miles to city A, so we're looking for the distance between the two. So what I'm going to do is set up 2 rate equations. First from A to B. We have distance equals velocity times time. So I'll call distance D right there. The rate there is 50 miles per hour, and the time we'll call T. Now from B to A, I'm going to use the same equation, but this time I'll do same distance, different rate, 55, and the time now is, if I'm driving for 24 hours, whatever time it took me to go there is how much time, 24 minus T, that I have remaining. So here's my system of equations that I can solve if I set them equal to one another. 50T equals 55 times 24 minus T. Distribute the 55, and that gives us 1320 minus 55T, and then we can add 55T to both sides. It gives us 95T equals 1320, divide both sides by 95. That gives us a time of 13.89. I'm not going to round them, I'm going to leave that in my calculator. But it asks for distance, so I actually need to take that time and plug it into either one of these equations to find that distance, so I'll just multiply it by 50. And that gives us a distance of 694.74 about miles. Next problem, the sum of 3 consecutive natural numbers is 1848. So let's just say that one of the numbers is x. The next number then, if they're consecutive, will be x plus 1, and the next one will be x plus 3. And I need to do the sum of those numbers. So it's x plus 1 plus x plus 2. Those would be the consecutive numbers to add to 1848. So I'm going to add the 3 x's together, and then add 1 and 2 to make 3, and solve this simple equation. Subtract 3, that gives you 45. Divide by 3, and you get x equals 615 is the first number, and then obviously 616 and 617. Okay, the next problem is going to have to be extra credit again because I can't solve this one either. So yeah, you guys might get some free points because I think I'm doing everything right, but I don't know. It's not accepting the answer. So A rectangle, it says a rectangle has one side on the x-axis and two vertices on this curve. So I graphed this curve right here in Desmos and copied the graph over. So we want a rectangle that touches this curve with maximum area. So I don't know what this rectangle is going to look like, but something like that. It wants us to find the vertices of the one that maximizes its area. So I called this little part right here x, obviously, and this part y. If that's the case, then this whole side is 2x, so is this whole side, and this side is y. So I figured the area of this rectangle would be 2x times y. And I know what y is, it's right here, as a function of x, so I just plugged in 8 over 2 plus x squared in for that y, and this would give us a function of area in terms of x. So the area in terms of x equals 2x times 8 over 2 plus x squared, which is like 16x in the top if you simplify it. And then I graphed this function right here. And I actually figured out what I did wrong now. I graphed it in Desmos, and here's what it looks like. So this is the area function in terms of side length x. Obviously we want to maximize the area, so we want that point right there. And I realized now what I did, the y coordinate here is area, 5.657, in one of the dimensions. Not area, but the corresponding y coordinate for this x coordinate. So I got to plug that 1.41 in for x to find the corresponding y value. So let me do that real quick. Yeah, and that worked. So the mistake I made was that worked. I got the on Desmos. This point right here is the maximum. That's x that maximizes the area, and that's the area. That's the maximum area. So I wanted x and y for the dimensions. I used that for y, but it's actually the area. So what I need to do is take this x, 1.414, looks like the square root of 2, and I need to plug that in for x right here to get a corresponding y. So that's what I did, and then I got my vertices, which were 1.414, comma 2. So you just had that 1.414, comma 0. Use your x that maximizes it, and use the corresponding y for this function. So this would be negative 1.414, comma 2. And this would be negative 1.414, comma 0. So this one's not extra credit. This is doable. I just made one small mistake at the end. Okay, then the last problem says you have 260 meters of fencing. That's a perimeter. And you want to enclose a rectangular area up against a long straight wall. What's the largest area you can enclose? So we're looking at area, which is length times width. We want to maximize that. So draw a rectangle. I'll call this length. I call this width. The perimeter I'll write in terms of length and width now. I'll write that as 2L plus 2W. So I have this equation and this equation. I want to maximize this one. So what I can do is get an area equation in terms of L or in terms of W. It doesn't matter. By substitution. And then I can maximize that area formula. That'll give me what W or what length maximizes it. Just kind of like we did in the last problem. So that's what I'm going to do. I need to combine these somehow. So I need to solve one of these for W. Or I'll solve it for W. It doesn't matter. But if I subtract 2L from both sides, and then if I divide by 2, that gives me W equals 130 minus L. Then I'm going to sub that in right there. That'd be area equals L times 130 minus L. Now I have a formula for area in terms of length. A function of area in terms of length. It's a quadratic that opens down, so I want to find that maximum point. I'll do that on Desmos real quick. Okay, you got to type it in, and then you got to scroll way up because it's a really narrow, steep, vertically stretched parabola. But at the top, 65, comma 4225 is the maximum. So that's meters for this. This would be square meters for area. So the maximum length is 65. The length that maximizes the area, and that maximum area is 4225. Now it wanted, it said the largest area, so we're going to give this answer right there, 4225, and it does say include units, so we have to do meters squared. Okay, I hope this helps.